good morning, good evening, good afternoon for everybody. So you are spread along the world. So it's a great pleasure to talk here again to PyCon Africa. It's a real pleasure for me. Thank you for the organization to invite me to make it possible, especially in these hard times, pandemic times. I would like to propose to you, all the people that are in the chat or in any other communication channel, please, if you have any questions, please stop me, send the message over the chat. If I have an opportunity, I can stop to talk and answer to you. I think that's better than a Q&A session in the end of the talk. But it's up to you to decide, right? But thank you so much. Okay, my name is Robson. I'm original from Brazil. I moved to Berlin 4 years ago to work here in Berlin. I have more than 16 years of experience here with different kind of technologies, but I'm proud to say that I learned to program with Python. Python follow all my career until now. So Python is part of my career. Until 5 years ago, more or less, I was deeply active on the Python Brazilian community. And after I moved to Berlin, and then I was a little bit more stealth on this. But if you wanted to reach me anytime, any question, if you want to discuss anything, so you can drop me a message on Telegram, Bsao0, Bsao0, or you can drop me a message on Twitter or GitHub. Actually, I'm working for the GitHub inside Microsoft, and my GitHub is the same, Bsao. So feel free to reach me out anytime that you want, okay? Today, my idea with the agenda is not a talk about code, but a talk about how Python fits in the data engineering roles around the world. Once that data engineer is majority dominated by Java tools, but Python has like a huge importance in the data engineer stuff, right? The first thing that you talk about anatomy of a data product, understand what exactly is a data product, and after you do a comparison between Lambda and capital architecture, just to make sure that the things is equalized between us. And then you talk about a data pipeline quality. If you are a data engineer, if you are trying to introduce new technologies or techniques about data engineer, feel free to reach me out as well as send some message. In the end, the most important question of your talk is where the Python matters, because you need to understand, well, which kind of tools in Python, which kind of libraries in Python can be used to you create state-of-the-art products for data, right? What's happening here? So a data product works like a software. It's any software, so you have basically inputs, you have a process, you have results. In our case, when you're talking about the data products, you are talking about how you collect the data. And to understand how you collect the data, you need to move one step back to understand the main concept of what is big data. Big data basically is the amount of data that you collect. But collect doesn't matter if you cannot extract anything from the data. For that, there's a theory of the 5 V's. 5 V's means that when you decided to have a big data, when you decided to classify your data as a big data, you need to understand more or less what kind of V are. For example, volume. Volume is the amount of data that you are collecting. But the volume doesn't matter, because you need to have it variated. Why? because you can collect like text files, images, sounds, or unstructured data. You have like a different kind of data that you need to collect. This is part of ingress, because once you collect it, you need to store it in a storage. In general, this storage is called data lake. It's like a lake when you have a lot of data, and then you can swim into this data and collect exactly what you need, right? When you started to process this data, or when you started to get insights from this data, you have a second step on this anatomy, that is the process. And the process, you have two mainly characteristics that you need to take care. One is the veracity. That means which kind of data you are working on, and the velocity. Doesn't matter if you have like teras and terabytes of data, if you take 2 or 3 months to collect, to process this data. So velocity is very, very important as well, right? And this happens because when you have your data lake, you extract subsets from this data lake, or you get small chunks of this data from the data lake, brings to the job and data sets, and from that you start to do the magic happens, right? And in another hand, when you need to egress, it means you need to serve your data to your customers. Your customers can be APIs, dashboards, KPIs, or a simple table in a database, wherever. You need to contain this, and you need to trust on that. This is the most important, because it doesn't matter if you process, you have a huge amount of data, but if you cannot trust this data, probably you lose a lot of time on your job, right? And as I mentioned before, the autonomy of a data product is exactly the same as a computer program. In the computer programs, when you put something to the processor, so you have files, you have windows, you have memory, and then you have functions and variables that manipulate these bytes, and in the end, the delivery is like a window, an API, or a result in a console. If you see, works exactly the same way. And if you imagine it like that, if a computer programming a data pipeline works exactly the same way, in the same theory for the testing, for the quality assurance, or how to maintain, to refactor your code, can be applied for the both scenarios, right? This is very important. When you talk about data engineer, you have two main concepts. You have the Lambda and Kappa architecture. These architectures were developed or were described to solve problems basically based on velocity, right? Because you needed to process a huge amount of data most part of the time, but you have slightly difference between how, for example, have like a disaster recovery, or if you needed to change some part of the data because we introduced a bug in your code and you needed to fix it. So I will explain both of these architectures are now. Lambda architecture basically is the de facto architecture in the market nowadays, right? So when you start to design your architecture in your new project, when you try to introduce a new data techniques in your project, you have two ways to think in data. You need to this data being processed in a real time or in a batch process. Batch process means you can have like a gap of time to process this data. You need to answer this question first because you are collecting the data. But let's imagine some scenarios. You are working in a bank, in a credit card issue, for example, in a bank. And then people started to use these credit cards, okay? When it happens, okay, You need to determine if a transaction is a fraud or not. It should happen in real time. Okay, it is very important. For this, you need to use speed layer because you receive the transaction. You need to do calculation in milliseconds. You need to use some technique in milliseconds to say this transaction can be or not a fraud, and then you can deny it or not. Is the first second. Okay. The second scenario is the batch layer. The batch layer basically is when you need to do aggregations. For example, daily visit users in your website, in your product. Along the last 24 hours, you collect all the data from these users. And then when this day finishes, you can in another day and process and extract all the metrics from the last batch. This is the batch layer. In the end, you have views. Views means that you can query your data, means that you can see the results of your data. And this goes to server layer. This is the mainly difference between the both layers in the Lambda architecture, right? 99% of the cases they use this kind of architecture resumes in a batch layer. And just if you need something really in real time for fraud detection or another thing more sensitive, probably you use a batch layer, right? When you use a Lambda architecture, you have like some pros and cons. One cons is that it tends to be more expensive than usually because along the way you are collecting data. When you started to collecting data, you needed to store the data. How much data you are storing step by step, day by day, so your bill increases because you needed to keep it stored. There's a lot of techniques to reduce this amount of money, but yes, this can be a problem because you have two problems here. You have one with the previous laws around the world, because sometimes you cannot keep data, otherwise you can keep data, right? And the cost of to keep this data stored, right? You need to teach your users to query data based in immutable data. It means that, for example, each new data that you receive from your ingress, they will never be updated or deleted. They just be inserted. Let's imagine a credit card was issued for you. You have a line in your table. Okay, now Robson has a credit card. The next line, Robson bought something with a credit card. Next line, Robson canceled this credit card. But I will never delete the data. I will just change the state of the data. For that, the people needed to understand how to query the data because it's a time series way to query your data. And then you needed to take care about that, right? The pros. The idea of the Lambda control is because they are reliable and safe. Why? Because if you introduce a bug in your pipeline or if you lose part of your data, you can go to your data lake again, get all that data and rebuild your pipeline, right? It's because they are fault tolerant. Because if you lose something, you can go to your data lake and rebuild everything from scratch. And they are really scalable because you can put more and more and more and more machines on your cluster and process more and more and more data as much as you want. And you have a nice thing that you can manage all your historical data in a distributed file system. It's making you more reliable and secure, right? In another hand, so you have like premature modeling. What means premature modeling? Is when you try to imagine all the things, right? So you are trying to have like a premature ideas to try to model your data, and then when you realize that that modeling isn't working for you anymore, it's hard to migrate. That technique that you learned about extreme programming long time ago about baby steps work perfectly on here. Model part of your data, put in production, change modeling, and then you don't have problem with that, right? As I told you, it can be expensive due to the amount of volume in the process, right? Separation of concerns can be hard as well. Why? Because sometimes you have like a small library inside your job, and this library is used for both layers in the serving in the speed layer or in the batch layer. It can be problems for you. It's one thing that you need to take care of. Perfect. What's Kappa architecture? Kappa architecture basically is a specialization of the speed layer in the Lambda architecture, right? Why? Kappa is not a replacement of Lambda architecture, but is an alternative to provide performance. Why? Because we receive like a lot of data and different scenarios, and then you need to process all these scenarios in milliseconds or just in seconds, right? It's used to process a stream, perform real-time process, especially for analytics. Imagine that you are working on e-commerce and you release it like an A/B test, and then you want to see in a real time how this A/B test is working, for example, right? This is a perfect scenario for Kappa architecture, right? But there's one thing that I love in Kappa architecture, that's it's permitting you to deliver new features, code changes, fixing bugs without any problems. You just need to deploy your code and everything will start to run automatically. No. You probably won't break the last code, right? Okay. In the Kappa architecture, so we always have like a well-defined event order. Why? Remember that I explained. So each event comes with a timestamp, with a date. It will never change. The data is immutable, right? So when you go to interact with your data set, with your data lake, you need to keep in mind that you started to work based on a time series, okay? This kind of architecture is well used for, as I told, for ads platform, fraud detection, social networks, and people who described this architecture try to solve the problems of the code chains. Because if you need to deploy a new code change, you need to stop your pipeline, deploy your code, warm your pipeline again, and make sure that nothing happens. The Kappa architecture, you just deploy the code and the flow will continue without stop, right? But for pros, you have something like that that's very important, that the Lambda architecture use less resources than Kappa architecture use less resources than Lambda architecture, right? And permits you to train your machine learn in real-time basis, because you always have data coming to you, and then you can train your machine learning models. Another thing that is nice about the Kappa architecture, that instead you scale verticality, you can scale horizontally. It means that instead you put more and more machines, you can just have like a big machine that you solve your problem, right? Another hand, you need to have more techniques to handle your exceptions in your code. So instrument your code, handle exceptions, log everything. This is mandatory for this kind of architecture, right? And if you have some severe bug, you might stop your pipeline, and then you need to fix it, and then you need to run one thing. It's called backfill, right? But it's important that's 10% of the time. Okay. Okay. Now you talk about the quality of the pipeline. So our, for me, just a small tip is that I learned in 6 years about my career. So I started to work as a software engineer, and one day, my manager told him, "So you have a project about data, so learn it and start to do." And then I transitioned my career to data engineer, and I loved it. So it's because I'm here to share with you, right? We will talk about quality of data pipeline, everything that I learned about the quality of data pipeline, right? The first thing that I learned it's about security. Security is mandatory because you have different levels. You have different levels to access your data. You have your data lake, you have sub data sets, you have tables ready for users, and you need to define for each kind of user, each kind of person who can access your data. This is the first step. How you define it? Access level for all the data levels. This is the very important because privacy matters always. Privacy matters. Okay. And another thing about security is try to use a common format. Common format means a format, a data format that you can interrupt with different technologies if you want, and then a common format that you can trust. I can give you some examples like Parquet file, JSON files, ABO files, or another serialization format that reduce the size. Security means separation of concerns as well. Who can change the code? Who can change part of the code? Because it's directly linked with the access level as well, right? And how you separate the separation of concerns for this part of code behaves to my business logic, and this part of code behaves to like a macro library. And then you can avoid hard code and duplication. In the data engineering pipeline is quite hard to reach it. You need to read, refactoring, talk. I spend more time refactoring and discussing my pull requests with my friends than coding, for example. This is just to understand, but the focus is the quality of the code and the pipeline. Automation is it's common for anyone, right? So data pipelines are codes. If you have a code, you need to version your code. This is my argument, right? So use Git, create branches, do the best for you to version your codes, to review your code, get the approvals, right? But there's one thing that's very important, and I love this part. Use the power of different tech platforms. So I will explain. Most part of the big data tools nowadays is writing in Java, Scala. I can, for example, Hadoop, Spark, Flink, right? But they have interfaces for Python as well. Why not use Python for that, but let the part of Java, because Java do it well, and you use Python for what Python performs well. Use the power. There's no problem with that. Code review and links. Keep your code beautiful. Not, of course, we are talking about the beautiful because people need to read this code from the pipeline. Pipeline tells us a story about data. It's very important. Different from a software that you have different ways to abstract and you have different ways to have your knowledge to abstract to make things more easy. The data pipeline codes in general, step by step of this pipeline tells a history about the data, how the data are being transformed, how the data are being changed, how you need to change everything, right? And of course, if you can use any kind of continuous integration server or continuous deployment. Automate everything. We are just programmers because you are lazy. I hate to repeat my job. So I love to be creative, but I love to repeat my job. So automate everything that you can in your code, in your process, right? Monitoring is another nice thing. In general, you introduce a lot of logs in our applications, right? But my advice here is let cloud helps you to monitoring your pipeline in your application, right? Just send out the logs, just send out the metrics, and set up some alarms. And if something goes wrong, so you receive like an email or a page or whatever. But I strongly suggest you to avoid any kind of vendor lock-in. It means it's simple, just to create a wrapper inside your application, just to hide the vendor that you are using for. In my case, I use a lot of Azure, but if you use Amazon or Google, just make sure to deliver everything related with monitoring to or logs to cloud. Tests is very important as well. Imagine that you started to create like a new data pipeline, and the first thing that you need to define is how your input you come into your system. Your inputs always must be deterministic. You can change anytime, but they need to be deterministic, right? Because you need to understand the behavior of your software, right? Focus in unit tests for all the pipeline as well. Each kind of transformation, each kind of slightly difference in the data, test it, right? And if you are able, I need to assume it's hard for me to apply regression tests here, but of course, I strongly recommend you to do it, okay? And it's one thing that everybody misses is to test the third-party tools, right? Let's imagine a scenario. You are developing a data pipeline, and you have dependencies of Apache Kafka, Apache Spark, for example. So you get it, put inside a Docker, and you need to test everything, right, together. Create this kind of a test end-to-end, include all your third-party components, because it's called the monkey test. So once you suddenly you shut down the Kafka, how your software behaves without Kafka. Drop the Spark, how your software behaves without Spark. They are able to recover it by themselves. You need to have an intervention. You receive an alert or not. So test the third-party components and do monkey tests is essential, right? Now is the time after I talked a lot. So let's understand where the Python matters here, okay? For the first, right? So everybody who starts in the data engineer, everybody who starts working with data, I suppose that the first word you listen is ETL. ETL means extract, load, and transform. Basically, it's a framework or a distributed computer framework that permits you to execute code in different machines with the same result, right? Nowadays, de facto, Spark and PySpark is the mandatory in the market. Of course, there's a lot of another players, but basically everybody uses Spark nowadays, right? For those who want to use a pure Python solution, I recommend Dask. Dask is a nice feature. There's a nice feature because you can interact with the objects inside Dask as you are interacting using pandas. If you know how to use pandas, you can just use Dask and do the magic. You can distribute your process along different machines as you are using pandas, okay? Luigi is a model in Python, is a library in Python that permits you to create complex pipelines. It means that you can create different tasks, and you can link these different tasks and create a graph between these tasks to say, if this task runs successfully, execute the next one. And then is infinitive. So you can have as much degrees or as much adds as you want, okay? If you are old school guy and you still want to use Hadoop, I recommend MER job, okay? If you are in Amazon or using Hadoop without Spark, MER job is a good thing. And Ray is similar to Dask as well, but honestly, I just played a bit, but I have no more information to talk about that. Another thing in the data universe is about the stream. Streaming basically everybody's using in stream as well. There's two main products in the market. One is Kafka. Kafka basically is the de facto streaming process as well, but you have Storm as well. I never used Storm, to be honest, but I used a lot of Kafka. And you have like a Python script that you can just plug into Kafka and work smoothly. I really recommend to you to use Faust, okay? If you want to use Stream and if you want to use Kafka for that. You can go in deeply. I think that my time is about to finish, but if you are interested, you just drop me a answer in a question answer. I can answer more for you. Okay, when you talk about analysis is not directly related with the data engineer, but of course they are complements, right? Pandas, I think that I don't need to introduce pandas, I guess, but I will do like I introduce. Pandas is like the full library for data analysis in Python, right? As I mentioned before, so they integrate perfectly with Dask. If you want to have some pure Python solution, you can integrate with Dask. Blaze is basically the same, but they integrate NumPy and Pandas directly with the big data. And OpenMind is for those people who works with big data, right? I never worked with Orange and Optimus. The documentation is quite complete, so you can explore more. Optimus, I heard nice things about that, especially because of data science workflow. And then you can integrate it directly with the PySpark. That's awesome. When I have opportunity to work on Optimus, probably I will try. Airflow. Airflow is a tool that permits you to create scheduler, monitors, and pipeline all together in the same tool. And Airflow is divided in two main components. They have a web server, when you have the UI to controlling and view all the health of your pipelines. And you have the schedulers and workers that runs all the jobs for you. And Airflow is extremely extensible. So independent of the tool that you are using, you can extend Airflow to use of your tool. Actually, I'm using with internal tools from my company. I extended, I use the open source tools. I really recommend you to give a look into Airflow and start to learn data engineering, data pipelines directly with Airflow. This is my advice. Okay? Testing. Testing is very important também. Everything is very important, as you can imagine, but testing. So you need to test your code. PyTest for me is the most mature Python tool, so very extensible também as well. So I can extend for different scenarios and behaviors. Okay. Nemesis permits you to generate fake data. It means if you need to generate like a huge amount of data to test one part of your pipeline, of your part of your model, so you can use Nemesis as you can do with the fake DB. And this link that I put in my presentation is a library that permits you to create unit tests using PySpark. Why? PySpark is a wrapper over a Java library, right? So you can use Python objects, you use Python objects with your code execute inside the Python interpreter, right? But sometimes you need to test the behavior in the Java side. These libraries permit you to write Python tests and test the global situation. Okay. Okay. When I told about premature modeling or how you define the schema of your data, some tools helps a lot. Let's imagine that today you are collecting the data of the weather, and then you have temperature, humidity, and rain, right? So you have modeling your application for receiving those three information. 1 month after, and you validate this input, so you can trust that all the data that are coming to your system, you can trust, right? 1 month after, you need to introduce a new data. Now you have like humidity, okay? Okay, you need to go there, change your schema to put a new column, a new field, a new document, whatever a kind of storage that you are using. And then you need to validate this new schema, making sure that the last schema is still working, right? And then you need to progress for the next steps. Those three levers that I'm showing to you do exactly this, right? If you want to validate the inputs of your application, or if you want to validate the schema of your files, you use Cerberus or you can use Voluptuous for that. For me, it's mandatory for any project of data, right? This is my advice for you. As I told you, it's not a talk about code, but more about the concepts. And I'm totally free to answer your questions, right? And that's all. I would like to say a big thank you. Obrigado, because I'm Portuguese. I like Portuguese. Feel free to reach me out in my email, Telegram, Twitter, whatever. Call me. I'm more than a pleasure to talk to you, share experience. Thank you so much, everybody.